Hello everyone. In this session, let us understand the concept of linked list. Like ArrayList, linked list also implements the list interface. Linked list elements, as we saw in the last session, they are linked together using the pointers. Now the methods of ArrayList and linked list, most of the methods are same, like methods to access elements, search, viewing the portion of the list, iterating, and checking size, and checking the list is empty or not empty. So these methods are similar to that of ArrayList, and there are some methods which are specific to linked list, such as peek and poll methods. So all these things we'll see in this session. So let us see how we can first create the object of the linked list. We will declare an object with var list is equal to new to instantiate the new object, and then linked list, and then in these angular brackets we need to provide the data type. Say I want to create a list which holds double values, say double. So this will be the constructor. Now we need to import the linked list from java.util. So import it. Now declaring a variable using var is specific to Java 10. You are using Java 9 or Java 8, then you will have to use reference type to declare the object, like we saw in the previous session for ArrayList. You have to declare the object with reference type and then you can instantiate it. So with this object list, let us see first we can add the elements. To add the elements, we have this add method. Let us say I want to add some elements, 1.1 in this list quickly. I added these 6 elements to the list. Now to search, we have a simple method that is list.get and then provide the index. Now index is not associated to a linked list like the concept of array list, but in this case index is, you can say, just the number. If you count the number of elements in the linked list, say 6, then the head will have the index 0 and then so on. In this case, if you say give me the second element, it will give you 1.3. So when you run this program, you will see 1.3 now. At any point of time, when you want to see all the elements in the list, you can simply sys out and write the object that is list. And when you run, you will see all the elements currently there in the list. Now after searching, how to update an element. Let us say I want to update a specific element from the list. That can be done by using set method. Provide the index. Say I want to change the element at index 2. Currently the value is 1.3. I want to change it to say 3.3. So the existing value will update to the new value. Let us check the value after updating as well. And when you run this code, you will see before update and after update. Pretty simple. Now after that, we have some methods to clear the list. Very similar to ArrayList, we can use simply clear, and when you run the program, over here you see nothing. All the items are clear. Can we remove a specific element? Yes. To remove a specific element, you can use remove method. You can remove using index. Say if you remove the element at 0th index, the first element will be removed. Or you can remove using the actual value. So you can say remove using the actual value. For example, I want to remove 1.6. Provide the value and element will be removed from the list. So when you run this program again, you will see 1.1 and 1.6 removed from the list. You can remove using the index or remove using the actual value. So these are the operations to access the elements. Access in the sense add elements or update elements. Insert. Now insert operation is pretty interesting. If I want to insert something in between, that can be done by using again add method, but in that case we have to use the index. If you simply use add, then the new item will be added at the next available slot, like at the end of the list. But if you want to insert something in between, let us say I want to add an item at index 3 and the new item is 9.8. So this new item will be inserted at index 3. So over here, at this place, the new item will be inserted, and then all these items will get new index. Like 1.4 will get index 4 and then so on. Add with the index will insert an item. Just add will add the item at the bottom of the list. So when you run this program, you will see a new item got inserted at index 3. This insertion is also available in the array list, and this is one of the major differences in between ArrayList and LinkedList, which we will see in the next session. So these are the basic methods to add, get, update, remove, and clear. Apart from that, we have some methods to search the list. Say we want to get the index of a specific item from the list, we can use index of, say, let me get the index of 1.2, that is first index. Also, if we have, let us say, multiple 1.2s in the list, and we can use last index of operation like we saw in the array list. Same, index of will search for the value and it will return the index of the first occurrence when it searches from the head of the list, and last index of will search for the value from the bottom of the list, and whatever first occurrence it gets, it will return the index of that specific. So in this case, index of 1.2 is providing 1, and index of, like, last index of 1.2 is giving 2, which is the second index over here. So index of, last index of, and then another method contains. Very important and useful when we want to check whether a specific value is present in the list. We can use the contains method, because list contains, and specify the value if the value is present. Let's say it is present true. If it is not, which currently is the case, then it will say false. So it's going to say false. Also, for the index of, if you specify the value which is not present in the list, say 1.99, then it will say -1 by default. If the value is not present, then the index of or last index of will provide the output as -1, both for ArrayList and LinkedList. Okay, so these are the search operations. Now, for viewing the portion of the list, again we have the same thing. I want to get the portion of the list from, say, second index to fourth index. It will get the sub list from the main list from index 2 to index 3. So when you run this program, this is the sub list from index 2, that is from 1.2, to index 3, that is 1.4. Apart from that, to get the size of the list, we have dot size, which will tell us what is the number of elements. ToArray will convert the list into an array. IsEmpty method will simply tell you whether the list is empty or not empty, and it will return true or false. And then let's look at the peek and poll methods, which are interesting in case of list over here. Let me comment these lines quickly. When you use list.peek first method, it will give you the first element, the head of the list. So if you want to retrieve the head of the list quickly, you can use peek first, that is the first element of the list. As there is peek first, there is also something called as peek last method. List dot peek last, it will give you the tail of the list. So quickly retrieve head and tail by using peek first and peek last. Similarly, there are methods which is poll first and poll last. If you do something like list dot poll first and poll last, those are also going to give you the first and last elements, but they are going to remove it. Like in case of peek first and peek last, it is going to give you the head and tail of the list, but it is not going to alter anything. It's not going to remove those values. Those values are still present in the list. But when we do poll first, it will give you the head and knock it off. It will be gone from the list. And similarly for poll last, it will give you the tail of the list and it will be removed from the list. Comment these and run the code again. Poll first has retrieved the head, that is 1.1, and removed from the list. Poll last has given 1.6 and then it is removed from the list. Peek first, peek last quickly gives you the head and tail of the list but does not remove. Poll first, poll last give you the head and tail of the list and also remove it from the list. These are the quick way of accessing head and tail of the list. Very simple. A lot of methods are similar to array list, but the actual operation that happens at the backend is very different. So this is about the methods from linked list, and I will talk to you about the differences in between array list and linked list, which is an interview question as well in the next session.